Good morning, everyone. Thank you for joining today. Just waiting maybe 1 minute more for other people to join, and then we can start. You can grab some water, can have grab some coffee, and in 1 minute we can start then. All right. I think we can start. So welcome everybody for today Advanced GitLab CI and CD webinar. I have actually helping me today Osnat and Ricardo. They are my colleagues from the CSM team. So just let me introduce again. Maybe for those who do not know me, my name is Mariana. I'm a customer success manager at GitLab, covering the DACH team and based in Hamburg. So, and Osnati and Ricardo, they are my colleagues, and they would help me with the questions. So before we start, you would see at the bottom of our presentation here that you have the Q&A section, so you can drop your questions there, and Osnat and Ricardo would be more than glad to support you during the process, okay? And then if there is any remaining questions by the end of the webinar, we'll also cover them. All right, so the agenda for today, but also before starting covering that, it is important to mention that this webinar is intended for those who already have some knowledge regarding GitLab, especially regarding the pipelines, the CI configuration, and are already working with that. So there would be not so new this information, but would also help with the current knowledge that you have. Just highlighting that we are in this session, we do not plan to cover the runner configuration and the CD part. Basically, we would like go with the basics of CI/CD, the pipeline structure, the architecture, the variables, how you can control your jobs using rules. We have also a little bit for our artifacts, and finally, some components, that includes and extends. All right, so I know that maybe this is a common graphic for you, but it's very important to mention and to go through the recommended process here at GitLab. So it doesn't mean that you cannot follow something on your side or something that your team it's already used it. This is what we recommend to achieve to get the best value from GitLab, including all the DevOps cycle. So basically here we can go with the create an issue. So let's say that when you on your team are discussing in implementing a new feature or changing something in your code, you would create an issue, and then this issue would be assigned to the team. And once you created a merge request, a new branch is created. This new branch, in this case, is the future branch where your team would work on. So you have the default branch, which you can consider as your production branch, and then you have the future branch. Then when you create the branch and commit your changes, the pipeline will start running. And if you have any security scans configured, those security scans will also run. You also have the review app, which provides an automatic live preview of changes made in the future branch by spinning up dynamic environments for your merge request. Then once you have the pipeline that was completed, you can discuss the results, any findings, if there's any vulnerabilities that were found, you can discuss that with your team. And if it is everything okay, then you can approve this merge request. Then you can also set special approves to special people. So maybe managers here, you can designate this part for some dedicated people. Once this the merge request is closed, then we have the other part of the process, which is the CD pipeline, which we run. We have the other security scans that were part after the deployment, and then the update of the security dashboards. Now here, something a little bit more, going more further, the CI and CD. So you have your code project, and then you want to commit it, and if necessary, add other related code here, which is also possible, for example, within the same repository. Once committed, the CI pipeline would be triggered. It would build your application, use GitLab runners that we would see now in the next slide, and run unit and integration tests to check if the code is valid. You can, after that, look at a live preview of your development branch with review apps before merging. You can deploy into different stages, tested stage or production state. And we also have some other environments, for example, Canary deployments that can also be used here in this part. Now that we discuss the CD, here it's a brief explanation about the anatomy of the CI/CD build. So we have the pipeline. There is a set of one or more jobs, and they usually are organized into stages. Then we have the stage, which are group of jobs that define when to run the jobs. For example, a stage that run tests after a stage that compile the code. Then we have the jobs, which will define what this pipeline will do. It's define what to do in this specific part. So, for example, jobs that can compile or test code. In this case, the runners, the GitLab runners, execute the actions declared on the jobs. You can have as many runners as you want, and yeah, multiple, important also here, multiple jobs in the same stage are executed in parallel if there are enough concurrent runners. And then finally, we have the environments. It's where you would deploy. And you have some example here: test, review, staging, Canary, deployments, as I mentioned, and production. Now we will talk a little bit more into the pipeline architectures. The main idea here, the goal is to apply some features, some architectures, some different architectures, with the goal to add more efficiency to your pipelines, to all your process. So maybe saving some time, making it more, it's faster and better for your for development. So starting, we would cover today this 5 architectures types. So we have the basic, the direct acyclic graph, DAG, or need sometimes, the parent and the child pipelines, which is one of the most known architectures here. Also the dynamic child pipelines, and multi-projects, which is also one of the most known between those architectures. Starting with basic pipelines, it is important to mention that it's the simplest pipeline in GitLab. The jobs run independently, sometimes on different runners. All jobs in a stage must be completed successfully before proceeding to the next stage. It is not the most efficient, and especially if you have a lot of steps, it can be a little bit more complex, but it is the easiest one to maintain. Here it is it is how you visualize. This is how the status, the visualized graphic of the pipeline, in this case, the basic one. We have the stages, the build, the test, and the deploy stage. And then under those stages, you can see the jobs that were defined in the pipeline. And then those icons, they have a meaning. It will also depend on how you were configuring your pipeline, which type of conditions you are using. So maybe here for the test B job, you can see that we set this job to allow failed. We'll cover those keywords later, those rules, but it is some possibility here, and actually it adds some efficiency to your pipeline, because if this job is not so important and can be failed, you are not blocking your pipeline for that. And in the deploy stage here, the deploy job, it has this engineer icon, which means that it was also added that this job needs to be run manually. So you need to actually go and click in this play button to run this job. Now we go into a more specific, more detailed architecture here. The needs, it is used if you it is good if you have long stages in your pipeline that are taking too long to complete, and it would the needs or the DAG, I like just to call it DAG, will speed up the process. So basically, you can set with that, you can set dependencies between jobs of different stages, allowing the jobs to run out of the order. So we saw before in the basic that they follow an order. So the jobs in the next stage will only start if the previous stage all the previous stages are successfully completed. In this case, we would work with the needs keyword to change this behavior and actually saying to other jobs that they can start running in different order. And we'll actually, again, here it's another way to reduce some time with your pipeline. So if you're looking to reduce your time of a pipeline, the needs, the DAG, actually, it's a very good option. So here we have an example of the need, of the usage implementing the need. So first we have the visualization of the pipeline, and then our YAML file. So we have a development of Android, iOS, and web apps in multi-stage pipeline. The test stage will run once all the stage of the build stage are completed. However, here we configured some dependencies. So the iOS test jobs can start when the previous Android builds are still running. So the iOS does not need to wait for the Android job to be completed. It can already start it. And we just added the needs keyword here. Just an important note, be aware that jobs cannot depend on artifacts from previous stages that are not listed as dependent jobs. This is one thing that you need to be aware. Here, it is a visualization, a graphic visualization of DAG. and you can access that on under CI/CD in pipelines, and then you have in the top the needs section. And once you select the path, you would see all the dependencies, how one job is dependent on the other, and it can also be a good way to understand if there's something else that you can do, and definitely, or if that matches your goals. Now moving forward with parent and child parents/child pipelines, they are very useful when you have long stage structure where all steps in a stage must complete before the first job in the next stage begins, and it's causing a lot of time. Configuration for the single global pipeline becomes hard to manage, especially in here for monorepos, hosting large numbers of projects and a single pipeline. The definition is used to trigger different automated process for different components. And the pipeline user experience has too many jobs and stages to work with. So with the child pipelines, you can split complex pipelines into multiple pipelines, allowing child pipelines to run concurrently. So here we have an example, and again, the visualization, which is a little bit different than the previous one, because we can see here that we have the downstream pipeline, and the other one is the upstream. So what that means? So what's actually happening here? So the child pipeline triggers other YAML files within the same project. And when it does triggered, another pipeline starts running, which is the downstream here. So in this example in specific, we have a monorepo that deploy individuals microservice A, B, and C. You cannot see the A, B, and C, but it's A, B, and C. And each one has its own pipeline that differs based on the microservice technology and needs. So you can see in the downstream that each one, we have different jobs, we have different child pipelines that start running. Here it's another example, the architecture, how like for monorepo again. So here we can see the YAML file configured when we use the child pipelines, and specifically here, the parent pipeline triggers a child pipelines. So the two jobs, build Windows and build Linux, are triggering other YAML files. The parent pipeline continues running after it have triggered the child. We would cover, like I mentioned before, but we'll cover the rules soon here, but just to give you a little bit context, because we're seeing some rules, you can use them to trigger a child pipeline under certain conditions as well. So the child pipeline here only triggers when changes are made to the file app cpp underline app folder. So this is also a very great option here for you. So if this pipeline only needs to run when there's this change, you can use the rules. We added here as an option also to combine both. We have now the dynamic pipelines. It's can also be, sometimes we refer to them as dynamic child pipelines, because they have like they're kind of the further features of the child pipelines. With them, you will dynamically generate the child configurations file from the pipeline. So it's a little bit different because we are dynamically generating the YAML files. So it allows you to generate configuration in your applications, pass variables to those files, and much more. This is also a great addition here to pass variables. And one of the main benefits for that is it keeps repositories clean and scatter YAML files. we have an example how the dynamic pipelines work. So still running a child pipeline for a static YAML file, you can define a job that runs your own script to generate a YAML file, which is then used to trigger a child pipeline. So in our example here, the job setup, we will execute a script that will produce the child pipeline configuration and then stored as an artifact. Then the test job will read the stored artifact and use it as a configuration for the child pipeline. Another benefit that's been very helpful, generating pipelines targeting content that change or build a matrix of targets and architectures. Our last architecture option here is the multi-project pipelines. Basically, a pipeline in one project can trigger downstream pipelines in another project and also pass variables to downstream pipelines. So here we are talking about different projects, not in the same repository. Very useful when building, deploying larger applications that are made up of different components that have their own project and build pipeline. So if you don't want to use monorepos here, for example, and you have your application is split in different projects, this is also a very useful feature for you. We have, again, an example how the YAML file will look like, and also the visualization of this pipeline after it completed. So to simplify, let's consider a simple case where we ask another project to run a service for our pipeline. You can imagine an app that is divided into multiple repositories, each hosting an independent component of the app. When one of the components changes, that project pipelines runs. If the early jobs in the pipeline are successful, a final job triggers a pipeline on a different project, which is the project responsible for building, running smoke tests, and deploying the whole app. Note that the trigger strategy keyword forces the trigger job deploy to wait for the downstream pipeline to complete before it is marked as success. If the component pipeline fails because of a bug, the process is interrupted, and there is no need to trigger a pipeline for the main app project. In the scenario, we are not using variables, but if your upstream pipeline has variables that need to pass to the downstreams, you can also do it. Very, very useful feature. Now we would cover the variables. Also very useful feature is one that is probably, if you are already using the CI/CD, you are used to that, using in different process and parts of your development. So let's cover just some important information here about them. So basically, just a basic information: the CI/CD variables are type of an environment variable. And you can use them to control the behavior of jobs and pipelines, store values that you want to reuse that later, and avoid hard coding values in your YAML file. You can use the CI/CD variables, the predefined ones, or you can define custom ones. And you can configure the variables directly on your YAML file or at the project or group level. So here it's an example how you can define those variables. So to create a variable in your YAML file, define the variable and the variable with the variables keyword. Please note that variables saved in the YAML file are visible to all users with access to the repository and should store no sensitive project configuration. So no tokens access, no passwords, nothing that has this sensitive level. So for those sensitive variables, you can configure that directly on the project settings, because this is another feature. You can just hide in the variable as the value, as you see here in the UI project settings, and only some specific rows have access for that. Let me just also here go to the next example. It is another option. It's the inherited variables, and with them you can create a new environment variables in a job and pass it to another job in a later stage. These variables cannot be used as CI/CD variables to configure a pipeline, but they can be used in job scripts. So in this specific example, the build job script save the variable as an env file, then save the env file as an artifact, and the jobs in later stage can then use those variables in the script. And you can, as well as also a note here, you can also pass the .env variables to downstream pipelines. So when we saw that in the multi-projects architecture that we mentioned, the variables that can be passed through other pipelines, here it is an example. We have also the pre-filled variables. It is a very useful feature and option. They are useful when overriding a variable or manually running a pipeline. And so how do they help? The users do not need, in this case here, that when you are, for example, running a pipeline manually, they don't need to select all the required variables from a drop-down menu and select which one they need. So here, the form will generate pre-filled variables for you and for your pipeline based on the variables definition in your YAML file. Very quickly, the level of importance of the variables, since we saw that there are different types and there are so many options with variables, which I recommend you to check our documentation. But just to clarify the level of importance, we have the first one. It is the variables in the manual pipeline and the scheduler pipeline variables. Project level, more important than group level, more important than instance level protected variables. And then inherited CI/CD variables, job level, deployment variables, and at the end, the predefined CI/CD variables. Now, the rules. We talk about the rules already. I gave you some example, but we would cover more examples and how you can actually apply rules for both your jobs and for your pipeline. So usually, I like to say that is a good option to decide when your jobs would run and when your pipelines would run. So for those who are looking for efficiency, to add more efficiency for our pipelines, the rules are for sure very important here and should be considered as an option. So we have the now the first part, when the pipelines run. So they would run with a new commit, with a new branch, a new tag, new merge request, manually through an API call, or schedulers. So those are the options when a pipeline will run. The rules for the basic, this is the common structure here for the rules under a job. So when you use the rules for a job, the clause if, it is one of the most used one, and it has a configured or predefined variable as an input. And we also have here, I separated the different rules, the options you have for clause, operators, results, and when options. So you can use them depending on the circumstance or the need that you have. Starting with, with the rules for jobs. So with rules, you can determine when a job will run or when it should be excluded. It saves a lot of time, and especially when heavy jobs do not need to run every time. In this slide here, we have the predefined CI/CD variables list that you can use, and the pipelines type that the variables can control for. So for branch pipelines that run for git push to a branch, like new commits or tags, the tag pipelines that run only when a new git tab is pushed to a branch, the merge request pipelines that run for change to a merge request, like new commits or scheduling the run pipeline, and the schedule pipelines. In this example here, so we can see that the job one will run for merge request pipelines and the schedule request pipeline, schedule pipelines, but not for branch or tag pipeline. So we are using the CI pipeline underlying source, and with the value assigned to this key to this variable will then tell to this job when it should run. Now we'll cover some examples. So the first one, we are using the rules to prevent our job to run for pipelines that were triggered by merge requests or for scheduled pipelines. And finally, the when rule, the when on success rule, tell the job to run if the previous stage was successful. Our second example, this job was set to create a container image. However, it would be manually triggered if the variable is equal to this specific string and the file as mentioned were changed. This example can be very useful for scanning tests when the change to specific files do not require some security tests to run. Again, this can optimize your pipeline and speed up your development process. Our last example for rules in jobs. Our job is conditioning to commit to the master branch here in this example. So if this commit happens, this particular job will be delayed and allow it to fail, which means that the pipeline will not be blocked by this specific job. The other part that we like to cover with rules, as I said before, that we can associate rules to tell them to the pipelines when to run and to also tell jobs when to run. Now it's the workflow rules when we tell the pipelines when it should run. In our slide here, we have the common if clauses for the workflow rules. So the examples and the details, how they can be applied. And in our YAML file example, the box here, we prevent pipelines for schedules or push branch and tags pipelines. And then the final rule here, the when and always, runs all other pipelines types, include merge requests and pipelines. We have for the workflow rules, we have variables depending on, which is in this case, it's our last case. And it shows that if the commit message contains this whip, then it won't run the pipeline. And if a tag is applied, then it also won't run. Otherwise, it will. Our next section is artifacts. Also, again, I'm sure that you are used to them, but just to cover some concepts, basic concepts, and how you can manage them in your GitLab platform. So artifacts are files stored on the GitLab server after a job is executed. Subsequent jobs will then download the artifacts before a script execution. So a build and publish stage will generate files that you'd use to deploy your application with your result stats. What GitLab allows here, it allows for saving artifacts in your local or object storage, and you can then use them in the same pipeline in subsequent jobs. You can also, as before, you can also apply here rules. So everything that we are talking, almost everything can be combined somehow, and the idea is to combine them and get the best value from the GitLab, and of course add some efficiency to your pipeline. So for the rules, I added here the options that you have. So you have the exclude, depends, when, and expiring, and how they would behave in this case for the artifacts. Where you can download in the GitLab UI, so you can download it on the pipelines page, on the jobs page, on a specific job, and in this case, if you'd like to consider the artifact browser, it's only if you are using the GitLab package registry. Now, the administration. There's two types of options here. So it would depend if you are a SaaS or if you are on self-managed. So in the SaaS, it is at project level here in the left. So you can decide if you would keep the artifacts from most recent successful jobs or not. And then for self-managed, you can actually configure the time of expiration and the maximum size of those artifacts. We have the packages and registries, and also mentioned that has some dependencies. So in our table, we are listed the package registry supported, and we have the package registers for private or public registries for a variety of common package managers, container registry, and secured and private registry for container images or built on Docker registry, the infrastructure registry, the current supports Terraform, and the dependency proxy, local proxy for frequently used upstream Docker images. And we can now, here with dependencies, you can control the artifact download behavior in your pipeline jobs. It's also, again, a way to control if other jobs will download it, those artifacts would need those artifacts or not. Because by default, jobs in later stages automatically download all the artifacts created by jobs in earlier stages. Configuring when the jobs actually need to download artifacts would help reduce pipeline running time and also increase its efficiency. You can also set a job to download no artifacts at all if this is this is also the case. So in our example here, defines two jobs with artifacts build OS X and build Linux. So when the test OS X is executed, the artifacts from build OS X are downloaded and extracted. The same happens for the test Linux job and artifacts from the builded Linux. The job deploy downloads artifacts from all previous jobs, as I mentioned, because of the stage of precedence. Some two additional details. The job status does not matter. If a job fails or if it's a manual job that isn't triggered, no error occurs. And if the artifact of a dependent job are expired or deleted, then the job fails. Our last topic for today, it is the included and extended keywords. Some examples and explanation how you can take some advantage of these options in your pipeline, actually also combining them. We already saw the included before in our child pipelines, but you can also use that in other cases and other scenarios, and this is what we will cover today here. A lot of information in this slide, but I thought that would be important to mention those. So as I mentioned, we saw the included before, but you can also use it in other options, and which actually included does, it configured the pipeline behaviors. So it's used to add external YAML files in your CI/CD configuration. For example, you can split one long GitLab YAML file into multiple files to increase readability. So here we have some options. So the include local is to include a file that is in the same repository as the configuration file containing the included keywords. The second one is the project and the file. So to include files from another private project on the same GitLab instance, you can use both the included project and included file. You can use the included remote with a full URL to include a file from a different location. And finally, you can use the included template to include GitLab YAML files templates. This is very, if some of you are already using security features, you would see that most of our security scanners, you can use them by adding the template to your YAML file. Now the extend, so the included, it is used for a pipeline behavior, and the extended is used to configure jobs. It is an alternative to YAML anchors, but it's more flexible and more readable. So just here, anchors, it's used to duplicate content across your document, duplicated or inheriting properties. So extends will allow you to enhance and reuse configuration sections. In this example here, the respect job used the configuration from the .test template. So the dot, because it has the dot in the front, is considered a hidden job, and they are only used for inheritance and don't run on their own. So the extends blocks means to inherit the reference block and override any hashes that are listed here. So what happens at the end when GitLab creates the pipeline? It performs a reverse deep merge based on the keys, merge the .test content with the rspec job, and finally doesn't merge the values of the keys. So we can see one before and what it becomes later. Our last slide for today, for our session today, it is the option of using include and extends together. We can use them across configuration files. So in this example here, you have a short script in the included YAML file. And now instead of copying, pasting, and complicate your YAML file, you can create a job that extends that .template job, just saying what image to run it on. So you can also see here that they use template image open and extends .template. It is what will simplify your YAML file. Now we have the time for more questions. I will wait a little bit more. If you have any other questions, you can drop them here in the Q&A section. I see that maybe there's one more, an outstanding one. My colleague Ricardo, yeah, she was just answered. I would give just 2 minutes more if you want to add more questions. You would receive an email with the content, with the slides deck and the recording of the session. So if you have any questions, would like to go back there and see again, you would receive that in a couple of days. I really appreciate your everybody here today, your time. Thank you very much. And please stay tuned for the next webinars that we will host. Next week, we have the DevSecOps compliance workshop. So I invite everyone interested in this topic to join us. And next month, we would have more. Thank you very much. I wish you a great day. And